Ricardo Rioda earned his degree in Computer Systems Engineering from Tecnológico Nacional de México, Instituto Tecnológico de Tijuana in 2024. He is pursuing a Master's in Engineering Sciences at the same institution. In 2019, he competed in the National Physics Olympiad. In 2024, Ricardo participated in the Womanium Quantum Workshop, the seminar on artificial intelligence and quantum computing, and NEO 2024, presenting research on multi-class evaluation of vision transformers for industrial welding defect detection. In 2025, he attended the Numerical Methods in Quantum Information Science Summer School at the University of Massachusetts Amherst and SPI Optics and Photonics in San Diego, California. He currently works in data science and ITG labs. His interests include mathematics, physics, quantum computing, and machine learning. Ricardo continues to deepen his expertise in AI and data analysis to solve real-world challenges. I give the floor to Ricardo Rioda.
Hello. Okay. Hello, everyone. I'm going to present our work titled Benchmarking AI Models for Intrusion Detection and Malware Classification. Okay. Now the problem statement is that cyber threats are growing complexity. So for that reason, we need most robust classifiers for tasks such as in intrusion detection and also malware classification. So in this work, we benchmark different classifiers using hyperparameter optimization for real-world applications and also real-world deployment. Okay, for this work, for the benchmark, we are using four datasets. They are public. We are using the network intrusion detection. This dataset contains network traffic data with labels for normal and also malicious behavior. The UNSW-MB15, it contains a modern intrusion dataset with 49 features, 49 columns, and diverse attack types. For example, DOS, exploits, for reconnaissance. Also, the Android malware dataset, it contains metadata and behavioral features. For example, for Android apps. And the Windows malwares dataset, it contains file features, for example, for Windows malware, families, and etc. The last two datasets are for malware classification, and the first two is for intrusion detection. Okay, for the state of art, there is prior work. For example, the data, the format of the data is tabular. So we are, for example, we're implementing a tab transformer. This is a model for a classifier for predicting any task. I know you can use it for a classification problem, prediction, but we are using this tab transformer. Also, the tabnet is another tabular classifier. There are works related to network intrusion detection, in this case using deep learning methods. Current trends in AI and machine learning for cybersecurity. This is a survey. And also there's a systematic literature about intrusion detection systems. Also evaluating the efficiency of artificial intelligence and machine learning for different cybersecurity solutions. So now our work, we are benchmarking, in this case, machine learning and also deep learning classifiers. For example, the tab transformer, the tabnet, and also we are implementing XGBoost and CatBoost to check the differences. Okay, so here we can see the models we are using. For the machine learning, we are using XGBoost, CatBoost. Both models are used for the two tasks. We have the intrusion detection system, intrusion detection, the problem, and also the malware classification. and comparing also some deep learning models, TAPNet and TAP transformer. So I don't know if I mentioned before, we are using hyperparameter optimization. So using Optuna, so we are using the models and play. We can say playing with the hyperparameters. Okay, so here we have a general workflow. This is a diagram. So we have two tasks. We have the intrusion detection task. It's about you have for example, you have a network and we want to identify if there's an normal behavior, abnormal behavior. A malware classification to detect if we can say there's software, or it can be also a file that is malicious. So in the datasets, we have two datasets for each task. The Windows malwares and Android malware for the malware classification task, network intrusion dataset, the UNSW-MB15 for this task, intrusion detection, using the models, using XGBoost, TAPNet, CatBoost, and TAP transformer. This part for the auto ML is we are only playing with the hyperparameters. So, and then we train the models and we evaluate the metrics. Okay, so in this case, each experiment corresponds to a data set. As I mentioned, the first two is the same task. Is in this case for anomaly network detection or intrusion detection. The last two is, for example, the data set is Android malware detection and Windows malwares. For the malware detection, malware classification, and using these classifiers, XGBoost, CatBoost, TAPNet, and Transformer for hyperparameter tuning. In this case, using the Optuna library. Okay, this is we have three phases. We have training. This data, all the data sets can see this data. Validation for the optimization, and testing is the final set of the data. That is, we can see that the models they never have to see this data, only at the end on the experiments. Okay, for experiments. Okay, these are the results for the first dataset, network intrusion detection dataset. Here, in summarization, we achieved better results using the machine learning classifiers. In this case, XGBoost, 99.77%. We have this. We achieved the better results using the XGBoost. Yeah, the accuracy you can see. Okay, for the second data set, the UNSW MB15. This data set is also for intrusion detection. For the classifiers, for example, XGBoost and also CatBoost, we achieve 100% of accuracy. For example, for the TAPNet and the TAP transformer, we didn't achieve the best results. Here we can see for the TAPNet some, we can say there are no very constant results compared to the machine learning classifiers. Okay, now for the malware classification task, for the last two datasets, the Android, here we can see also the machine learning classifiers, we achieve the best results, 99.10% of accuracy, only surpassing the use of deep learning models, for example, TAPNet and TAP transformer. Finally, we can see here CatBoost also surpassing results compared to TAPNet and TAP transformer. Okay, now with the state of art, we talk about previous work, but in this case they don't use the same datasets, but they use similar datasets but for the same task. For example, we found intrusion detection. They use this dataset and also this dataset. They have achieved 88% of accuracy and almost 100% of accuracy, 99.96, different dataset, but same task. So this is the comparison with our results. Okay, now for the conclusion, we evaluated in this work machine learning versus deep learning models in four cybersecurity datasets. We get the best results only using the machine learning models. As I previously mentioned, we use XGBoost and CatBoost, and also hyperparameter optimization. We use hyperparameter optimization, and the deep learning models. We achieved good results, but not as good results as the only using machine learning models, as XGBoost or CatBoost. Okay, now for the future work, we would like to implement quantum computing for feature encoding or feature extraction, also to increase the training speed, because for using Optuna, we need to run, for example, 100 epochs. So it depends on the dataset. If the dataset it contains a lot of samples, that increases the time. So using quantum computing obviously will reduce the training time. Also explore some other techniques, for example, neural architecture search or meta learning. Also, we could implement synthetic data, and at the end, we can see that we have achieved 100% of accuracy, but for a real deployment, that obviously the results they are not going to be as good as they seem. Okay, so that's everything. Thank you.